This presentation explains the extraction of the data from source, transformation of data to OMOP CDM, and loading it on the BC-Link platform. This diagram gives an overview of the process involved with the data partners and the CO-CONNECT team to successfully convert data into OMOP CDM by ensuring the data is not accessed and manipulated by anyone except the data partner. The first step of the data standardization is data preprocessing and metadata extraction carried out by the data partner. More details on this can be found on part 2 and 3 of the video series. In the next step of the data standardization, the data partner will send white rabbit output or metadata extract and the data dictionary to the CO-CONNECT team. The CO-CONNECT data team will use these files as an input to the CO-CONNECT mapping tool and generate OMOP conversion rules, a JSON file. Think of this file as a document containing guidelines for OMOP conversion of the data. For details, please check out part 4 of the video series. As the last step of the data standardization, the data partner will run the CO-CONNECT tool's Python package, which will extract pseudonymized data and transform it into OMOP, guided by the mapping JSON file, and load it into BC-Link application. In this presentation, we'll look into this section of the data standardization in detail. This flow diagram gives an overview of the infrastructure requirements to run a successful ETL process. The infrastructure will be set up on the data partner's secure network, and the CO-CONNECT infrastructure team will provide support and assistance to the data partner during this process. The first step is to set up a virtual machine with at least minimum or recommended specifications. Once the VM is set up, the BC-Link application and the CO-CONNECT tool's Python package will be installed on it. BC-Link is an application developed by BC Platforms which is running on PostgreSQL database. And CO-CONNECT ETL Tools is simply an in-house Python package to automate the ETL process. The CO-CONNECT ETL tool makes the ETL process completely automated and customizable as per data partner's needs. The automation specifications are set in the configuration YAML file. The automated feature is especially helpful for regular data dumps, such as fortnightly, monthly, yearly, etc., or cases where an entirely new dataset or datasets are mapped. For example, the initial mapped cohort had dataset with symptoms, but later datasets for serology and PCR tests were also included. Or in cases where new types of records are mapped. For example, a cohort records data for patients with multiple comorbidities, but in the first iteration, only certain comorbidities were mapped, and the remaining were mapped later. In cases B and C, a new JSON rules file will be provided to the data partner that reflects these changes and additions. The criteria and the level of automation will be defined by the data partner in the configuration file. The automation is completely customizable to cater for the needs of the data partner. To define the minimum level of automation, the required criteria is to provide the data, JSON file, and output folder location. Additional options can be activated by optional functionality, such as cleaning or clearing the BC-Link tables or pseudonymization of IDs, etc. For more details, please check the link on the slide. This is the ETL process flow once the VM is set up with BC-Link. SSH into VM and copy the required files, then take the appropriate user controls. After that, create a project directory to install the tool in a Python virtual environment, and then run the transformation commands. Here's a quick demo to show the installation and execution of the CO-CONNECT ETL tool. When the CO-CONNECT ETL tool is run, the data from the CSV files is transformed to OMOP CDM and loaded to BC-Link tables. Every time the tool runs, it also generates a log file. This file does not contain any data and only shows information of the transformation. This log file is then sent by the data partner to the CO-CONNECT data team to confirm that the transformation was carried out successfully. CO-CONNECT ETL tool also allows semi-automated approach, which could suit scenarios in which data partner has complete or part study cohorts which require one-time or infrequent transformations. In this case, the CO-CONNECT ETL tool is installed on a local machine and performs the extraction and transformation of the data outside the VM, and outputs OMOP CDM in a TSV file format instead of directly exporting it to BC-Link. The TSV files can then be copied to the VM and uploaded to the BC-Link using command line interface or graphical user interface. This is the process flow diagram to run the semi-automated ETL process. The data is copied to and the tool is installed on the local machine of the data partner. The transformation process is run, which outputs TSV files. These files are copied to the VM where the BC-Link is installed, and then the files are uploaded to the BC-Link using graphical user interface or command line interface. This quick demo shows the extraction and transformation of the data files into OMOP CDM and TSV file format. Once the data is transformed to OMOP CDM, the TSV files can then be copied to the VM and uploaded to the BC-Link using the graphical user interface as shown on the slide or command line interface. The CO-CONNECT infrastructure team provides the support in performing this part of the process. BC-Link is connected to BC request. All the queries are run against the data present on the BC-Link, and only the aggregates are returned against the queries that are run on the HDR cohort discovery portal. For details on how these queries are run, please watch part 1 of these video series. This is an example of a query returning aggregate number of records from different cohorts with either male or female sex.